Hi, it's Ronnie Chowdhury here, and welcome back to my tutorials on concurrent C++14. Today we're talking about the simplest of structures, loops. Here I'm creating a simple for loop that just creates a vector of random numbers. Very easy. How would you do that in C++14? Well, we use an stl function called generateN that takes three parameters. First parameter is where you want to put the results. Second parameter is how many of them. Third parameter is what's the function you want to call to generate these numbers. It's a lambda function, so you can do whatever you want as long as it returns a value. So in this case, we do the same rand function. Keep this lambda function in mind for later, because we're going to come back to this simple for loop in a second. Quick digression, I'm going to read some numbers from the standard input using the same approach. Here we use copyN with an iStream iterator, done in exactly the same way, fills up the vector, we pre-allocate the vector to reduce the memory burden, and then we go forward. I would also point out that vectors can also be optimized, but we're going to come back to that later on in this series. Let's sum up these random numbers using accumulate, and let's do it again using accumulate and a lambda function to multiply all the values by 2. Lambda functions are a key, and make sure you keep this in mind throughout all these videos. They allow us to do concurrency in a very declarative fashion. Let's do one more example where we do the same kind of accumulate, but this time using an index. You shouldn't really need to do this, and it's not great for concurrency because now you have a dependency between two independent variables, the previous value and the next value. However, you can do it, and also C++14 makes it easy to see that you've got a mutable value by explicitly stating that in your lambda capture. Concurrency is a major part of these tutorials. So now that we've got two accumulate functions, we can see that they depend on the generated numbers first. So that's the first sync point. But the two accumulates can run completely independently. So let's parallelize them. In C++14, you could do that in a thread pool completely automatically with a simple function, async. So let's launch these two. There we are. And we do both the launch function and the embedded accumulates all as lambda functions, so we can do it as a single one-liner. No type declarations needed at all. We're making sure we're using initializer lists here, and this means each thread will have its own copy of the numbers. Writing multi-threaded code is hard, especially when you have dependencies all over the place and you don't know what needs to be shared and so on. One thing that a lot of people think about is, how do I break out of a for loop? What are you trying to do? You're trying to look through a vector of values and then see if all of them match a certain criteria, in which case you'll go through the whole loop, or you're going to see if any of them match a criteria, and then in which case you break out of a loop. Unsurprisingly, STL offers that straight away. So let's implement that in the C++03 way, 14 way. Pretty much you should be able to cover all your loop possibilities, I think, using these techniques, except for one, which is the while true loop. That's the only one that's not handled by an algorithm, because that has no output. If you think about it, this any of and all of functions are testing every value in the loop. Immediately you should be thinking, I could be simd'ing this because each value is completely independent from the other. You'd also be thinking, I could do a parallel for loop because, again, each value is independent from the other and therefore they could be run in parallel. Both are opportunities that we will explore in a later video.